So just to follow up on our discussion from part one, we've just done a variance analysis for direct materials, and we see that we had a total variance for direct materials of -1, which was a favorable variance, which was not a very significant number. However, when we decomposed that variance down into a price variance, we found that we had a favorable variance of 12, and when we looked at quantity, we had an unfavorable variance of 11. And so at first glance, we could look at this and say that, well, since our price variance was favorable, maybe the purchasing group or the people in charge of purchasing the direct materials did a great job. Another version of that, or another scenario, could be that the price of direct materials in the marketplace fell. And so that's why the price is lower. So maybe it didn't have anything to do with our purchasing group's expertise. In fact, maybe the price fell even more than $1 and our purchasing group did not do a good job. They should have got it for even cheaper. So there are a lot of explanations there that need to be understood better. On the production side, the quantity side, we used 1 more gallon than we had anticipated, 12 versus 11. Was there a problem with the efficiency of the equipment? Did it require more material to purchase those than we had anticipated? Was that a design problem with the product? Was it an issue with the equipment? Or was it simply just inefficiency from a production point of view? For instance, was there simply waste, much more wasted product in the production process? And so maybe those were issues with the production people. Or was it something production wasn't able to avoid? Maybe there was some type of fire or other damage that occurred in the plant, and some of that direct material, raw material, was consumed. And it was of no fault at all from the production point of view. So again, all those types of scenarios need to be looked at. Another possible scenario is that there's an interrelationship between the two variances, and maybe you can think about that. You could pause and think about it for a moment. But it may not just be as simple as the purchasing and the production being separate. They could be interrelated. For instance, in this case, perhaps some cheaper product was purchased, some inferior product was purchased, but because of that, it required more product or more of that ingredient to produce the final product. So for instance, you could imagine buying a more watered down or a more deficient raw material that you would get cheaper, but it would take more of that to ultimately produce the final product. So it wouldn't be production's fault, it would actually be purchasing's fault. So again, all those could combine together to produce this, and that would be part of the investigation that would need to go on to better understand what's producing these variances. So again, very important. Most companies do use this method to look at standard performance versus standard each month, and they do go through it in quite a bit of detail. Now, this visual picture I drew in this method of coming up with these variances, you can use that method. That seems a little bit easier because it's easier to understand how those variances are arrived at, or you can use the formulas in the book. So for instance, the price variance would simply be the difference between actual, so price variance would be actual minus standard price times actual quantity. Okay, so that would be how you would determine the price variance, and then there's a similar equation. Well, it's different, but also an equation to determine the quantity variance. So you can also use those equations. Just make sure that the algebra is correct and the signs work out the correct way. and that you pay attention to exactly which numbers you're using in those formulas, because it will make a big difference. Just a couple other key concepts to note, and I'm going to pause and write those down real quick. So some key concepts in this chapter, just to remember, is that for variable cost variances, and these are for direct materials, direct labor, and variable factory overhead. So all of the variable costs. And remember, variable costs, the cost per unit is going to remain constant no matter what the volume is. And so for those, we're just going to measure actual versus standard. So that's going to be pretty straightforward. So what we did in direct materials, we'll do the same thing in direct labor. We'll do the same thing with variable factory overhead. We're just going to look at actual versus standard, and that's going to provide us with the variance. With fixed cost variance, and where we're just going to see that is with fixed factory overhead, that's going to be driven by volume. And so there we're going to do a different type of calculation. And we're going to come to that in our part 3 lecture video. But there we're going to compare the budgeted 100% normal capacity. So in other words, what we had originally anticipated our volume would be when we prepared our budget and we established our predetermined factory overhead rate versus what the standard is. And remember, our standard is going to be based upon the actual production that we do have. So in effect, we're basically comparing what our budgeted production is going to be versus what our actual production was. Because remember, fixed costs do vary with volume on a per unit basis. So that's going to affect the cost of our units. If we produce more units, the cost per unit is going to be lower. And if we produce less units, the cost per unit is going to be higher. And so we're trying to capture that variance purely from a production point of view. And remember, this is absorption costing. So we are allocating all costs to the product. So again, more products produced, lower cost per product from a fixed cost perspective. And so we want to be able to capture what that variance is by looking at what the difference is in the volume versus what we had anticipated our budgeted volume to be. And third, whenever we're talking about standard quantity, if that's not a given number, what we're really looking at is the standard quantity per unit times the actual units produced. So in other words, if it takes 2 hours to make each unit and we make 1,000 units, then our standard quantity is going to be 2,000 hours. So, but it's going to be based on the number of hours or the number of units, the quantity per unit times the actual amount of units that we produce. So again, it's always based upon the actual number of units that we produce, but the standard quantity allowed per unit. Okay, so we'll come back to that. So I'm going to go ahead and set up an example and we'll work through that. So I've set up an example here. Slide that up a little bit. So we've got, we're manufacturing 2,000 units. We've got actual and standard. So for direct materials, we've got actual price of $10. We've got an actual quantity of 2,100. We'll call them gallons. We've got a standard price of $11 and standard quantity, we'll call these ounces, 1 ounce per unit. For direct labor, we have $12 as a rate per hour, and we have 14 hours. And here we have actually, sorry, that's wrong. I've got those in the wrong place. Let me correct that. Sorry about that. For direct labor, we have a $12 rate, we incurred 8,200 hours, and our standard rate is $14, and the allowable standard per unit is 4 hours per unit. And then we'll come back to our factory overhead later. So let's take a look at our direct material variance first. So we've got an actual price of $10 per unit, an actual quantity of 2,100 ounces, and so our total actual cost is $21,000. Our standard, let me move this over just a little bit. Our standard price is $11 per ounce. And our quantity is 1 ounce per unit. And remember, for standard quantities, we want to have the standard quantity allowed per unit times the actual number of units. So in this case, we have 1 ounce per unit times the actual units, which is 2,000 units. And that's going to equal 2,000 ounces. That would be our standard. So again, standard quantity per unit, which is 1 ounce per unit, times the actual number of units. And these are 2,000 units. That's our actual production. So here, we multiply that out, we get $22,000. So for our total variance, we're going to take 21,000 minus 22,000. We're going to get minus $1,000. And a minus is a favorable variance. So our total variance is favorable by $1,000. Then what we're going to want to do is we're going to look at our price variance and our quantity variance. If we're looking at price, we want to isolate and hold constant, rather, our quantity. And if we want to look at quantity, we want to hold constant our price. If we multiply those together, we're going to get $23,100. So that's just a matter of subtracting. So for price variance, we subtract the 21,000 from the 23,100. We're going to get a minus 2,100. And again, a minus would be a favorable variance. We can see that's favorable because we can see our price is $10 versus $11 standard, and that is going to be favorable. So our price is a favorable variance because it's less than our standard. Quantity, we're going to subtract those, and we're going to end up with a positive 1,100. And that would be an unfavorable variance. And again, we can see that because the quantity we used of 2,100 is greater than the 2,000 standard quantity. So that's our direct material, our 3 variances. For direct labor, we're going to use what's called rate and time. So the rate per hour, our actual rate per hour, is going to be $12. And the actual number of hours we incurred was 8,200 hours for the production of these 4,000 units. That will give us a total of 98,400 units. I'm sorry, $400. Now our standard rate is $14. And again, standard quantity is standard quantity per unit times number of units, actual production. So here, 4 hours per unit are allowed. That's our standard quantity per unit times our actual hours, or actual units rather. Actual units are 2,000, and we're going to actually come back and finish this up in the next part.